DevCon. And then we're going to take a closer look at what we've been up to with the Zebra consensus node. We're also going to talk a little bit about what's been happening with Frost for the past 10 months. And we're going to end with a nice little demo of the user flows for signing a Zcash transaction using Frost. So who are we? Who is the Zcash Foundation's engineering team? There are 7 of us in the team. And you may notice if you add up the numbers, they don't quite add up, but that just means that some of us wear multiple hats here at the Foundation. To start off, we have 1 platform engineer, and that is Gustavo. We also have 3 cryptography engineers, which are Conrado, Marek, and Natalie. Then there are the multiple hat-wearing protocol designers, and this is Arya and Conrado. We have 2 core Rust engineers, Alfredo and Arya, and finally there is me, the engineering manager. So what does the Zcash Foundation's engineering team do? Well, we work on a number of different areas and projects here. First of all, we do DevOps, and part of that is doing continuous integration and delivery of our software. And that means we're constantly building, constantly testing, and merging code changes. And if there are no failures or regressions, we then deliver those changes to our main branch and deploy nodes on the testnet. We also run some key Zcash network infrastructure, such as, for example, one of the DNS seeders for both testnet and mainnet. And these DNS seeders are an important part for new nodes to bootstrap onto the Zcash network. Finally, on DevOps, we provide Docker images for Zebra in order to make it easier for anyone to run our software on their chosen platform. In the future, we may provide some other artifacts for ease of running Zebra and the new Zcash Stack on the Zcash network. One of the other projects that the engineering team works on is Frost, and Conrado will give a little bit more info on what the Frost project is. But some of the work that we have done on Frost are the informational RFC, which specifies the Frost protocol for 2-round Schnorr signatures. We also wrote a reference implementation of this specification in Rust. And we've also been working on a Frost server and client, which will make it easy for Zcash wallets to implement Frost signature workflows. Finally, we also work on the Zebra project, which is the name of one of the Zcash consensus nodes along Zcashd. And by the end of this year, we hope it will be the sole consensus node on the Zcash network. Moving on, these are some of the highlights of what's been going on in Zebra in the past 10 months. And that is 10 months because that's when we last gave an update at ZconVI. So first of all, we've made a number of improvements to Zebra to make it easier to use and deploy. We also have tried to make it more performant and secure. We worked on implementing the necessary updates for Zebra to support network upgrade 6. And we've also been focusing on enabling Zcashd to be deprecated and working on the new stack for the Zcash network. And this will include Zebra as the only validator node on the Zcash network. So now with that, I'm going to hand over to the rest of the team, and they will tell you a little bit about some of these improvements and these things that we have doing in a bit more depth. And we will start off with Alfredo, who's going to tell us a little bit more about the improvements we've been making to the mempool.
Hi, let's talk about the recent improvements to Zebra's mempool. These changes focus on making transaction validation more efficient and making sure transactions propagate correctly through the network. We identified and fixed several issues related to transaction validation and block advertisement. We'll go over some of them now. So a bug was reported where 2 transactions were submitted to Zebra sequentially. The second transaction attempted to spend transparent outputs from the first, but since the first transaction was unmined, the second transaction was rejected. Previously, Zebra will always reject such transactions. Fixing this issue enables Zebra to verify these transactions properly. This fix also allows Zcash text addresses to function correctly within Zebra. When a transaction is submitted to a mempool, multiple verifications are performed, but not all of them occur at this stage, since the transaction is unmined. Contextual verification, however, is performed at this point. Before this fix, verification was duplicated in the block verifier, which calls the transaction verifier and makes the same checks again. Now we perform this verification only once, improving overall blockchain verification performance. During private testnet dry run we did for NU6 with the ACC team, we found that when a miner successfully submitted a block, it was in some cases not propagated correctly to the network. We identified and fixed this issue, ensuring that mined blocks are now broadcasted correctly. Now let's move to Aria, who is going to talk about the network and the security fixes we did in the last time.
Thank you, Alfredo. So in Zebra Network, in preparation for Zcash deprecation, Zebra now scores and bans misbehaving peers. That is, if a peer connection sends advertises blocks or mempool transactions that are semantically invalid in a way that the peer node should have been able to check that it was invalid, those peers will be considered misbehaving, assigned a score, and eventually, if the score reaches a threshold, those peers will be banned and disconnected and rejected in future connection attempts. This is similar to what Zcashd does, and it will be necessary for once Zcashd is off the network and Zebra is the only consensus node implementation. There was also a network protocol implementation bug that was discovered during private testnet testing, such that Zebra returns only, or was returning only 158 block headers. This would be correct if it only had 158 blocks after the block locator that was sent to it, but it was doing this to avoid multiple requests, and essentially it was a bug in the implementation that was fixed. The inefficiency that it was added to try to work around has been fixed on the Zcashd side, to my knowledge, and if it hasn't, regardless, it won't be an issue once Zcashd is deprecated. Um, in other network fixes, we've added long-lived node deployments to our CI so that once we publish a release of Zebra, both testnet and mainnet deployment of it will be run by our CI, and this is to improve the network stability in general, testnet stability in particular, and our CI stability. And finally, we've extended tower batch control to allow for flushing requests in the queue to the Halo 2 verifier once the total number of actions between them reaches a threshold, rather than the total number of requests, because there could be a great number of actions for a given proof. And this allows us to do batch validation of orchard proofs. And there's a draft PR open for this right now. And then in Regtest and Custom testnets, we've made a number of improvements generalizing the configuration options that Regtest is using to be defined by the user on custom testnets. We've added the experimental internal CPU miner for testnet. This was part of the hack sprint. It was Tior's project from last year, but the Equihash PR that it depended on has just recently merged. So this is just being restored now and should be available in the next version of Zebra. We now have support for invalidating and reconsidering blocks in Zebra's non-finalized state, thanks largely to contributions from Elijah Hampton. And this is going to be part of enabling DEX support as per comments left by Han on the issues. And then there are some additional configuration options that have been added to not just custom testnets, but also Regtest altogether, including the halving interval and configurable funding streams, which were added as part of the NU6 work. And with that, I'll pass it off.
Yeah. So we're going to talk about a little bit about Docker, which is basically our main way to make deployments and also to use Zebra for with the users. We have some new documentation on our Zebra book, and we've been working on improving even that documentation also in the repository, so it's easier to deploy Zebra with Docker and to use it with other tools that are part of the ecosystem. We even recently had a community call explaining the process, not just like with Docker, but also with our CI and our CI and CD across the repository with Zebra. And in this call, we even went through some of the new examples how to use Docker and the easiness of using it and deploying Zebra using Docker. Some of the upcoming releases of our artifacts with Docker, we will have better user permissions management because we previously had we were using the Zebra binary with the root user. Then we made some changes and improvement to that. We needed to handle some edge cases. For example, if you mount a volume from your provider or from your computer, and those volumes have like different permissions that the ones on the container, then we need to change the permissions of those volumes before actually using it with Zebra. But without a actual user with like a root user with permissions to make those changes, so that it was a little bit hard to get over those edge cases. So we made some new implementations using Gosu. So those new implementations allow us to, for the users, actually allow them to be able to mount those volumes and not having to care about the permissions specifically, because those will be changed to the Zebra user of the Docker image. And we also disabled the RPC ports by default. So this is basically for security reasons. So the images that you'll have downloaded and initialized by default from the Docker registry will have these disabled. You can enable those though through environment variables. And we have even made some improvements on how to handle environment variables. But part of those improvements is that we now include a predefined server configuration file on our Docker images. Those are in the repository, so you can see like what's the default configuration file that we're using. And it's also to make it easier for users to understand like beforehand what will be their default configuration that Zebra will be using. And then I'll pass it to Alfredo so he can continue with some other subjects.
Thank you. Let's now cover the recent improvements to Zebra RPC interface. So as more users and services transition to Zebra, we've been working to improve authentication, compatibility, and performance. These updates make Zebra RPC more secure, efficient, and aligned with the needs of the ecosystem. Previously, Zebra RPC methods were freely accessible when enabled. Zcashd supports two authentication methods, but username and password authentication was deprecated in favor of cookie-based authentication. We have now implemented the same cookie method in ZebraD, and it's enabled by default. Users can disable it via configuration file before starting ZebraD, but this is not recommended. To maintain compatibility with Zcashd, we originally used the parity RPC grades, which served us well for a long time. However, these grades were deprecated recently by parity in favor of JSON RPC with an S. Migrating to JSON RPC was not trivial, but it was worth the effort. The new library is well maintained, meets all our needs, and allowed us to simplify and improve our RPC code. Since JSON RPC is used in several major projects, we expect a long-term support and stability. Historically, Zebra's RPC interface was designed around specific use cases, such as supporting live wallet D and mining. Now the main use case is Zcashd full node deprecation. Based on discussions in the Zcashd deprecation meetings, we have extended multiple RPC methods to support broader functionality. We received reports of incompatible error codes, particularly for the get route transaction and the send route transactions RPC methods. We fixed these discrepancies and we reviewed all the RPC methods to ensure the consistency between ZebraD and Zcashd. Apart from extending methods and improving compatibility, we're also implementing new RPC methods that are needed for Zcash deprecation. Some of the recent additions include invalidate block and reconsider block, as well as Regtest specific RPC methods like generate and stop. Now I leave the space to Marek to talk about the NU6 network upgrade.
Thank you, Alfredo. I will now talk about NU6 briefly. NU6 activated intentionally in coincidence with the second halving, which happened on November 23rd last year. And the halving reduced the block subsidy from 6.25 SEK to 3.125 SEK. And to cut a long story short, we implemented NU6 according to the zips you can see on the slide. The main zips there are zip 236 and 1015. Zip 236 makes the issuance rate exactly predictable by mandating that miners always claim the whole block subsidy for each block and the block's transaction fees. And ZIP 1015 describes the lockbox, which is the funding approach the community decided to go forward with for NU6. Maybe this is a good opportunity to describe the lockbox a little bit, since there seem to be occasional misconceptions floating around it. And what might be confusing there is that there is no data related to the lockbox itself on the Zcash blockchain. So when a miner mines a block, they send exactly 80% of the block subsidy to an address of their choice. And then they send 8% to an address controlled by the Financial Privacy Foundation, and then the remaining 12% of the subsidy is omitted from the Coinbase transaction of the block. Now, when Zebra receives such a block, it looks at its height, and if this height belongs to the range for which the lockbox mechanism is active, then Zebra adds the 12% to the so-called deferred value pool balance. And this balance essentially represents the lockbox, and it lives only in Zebra and Zcashd. The balance is analogous to other value pool balances we have in Zcash, namely the ones for Sprout Sapling and Orchard and one for Transparent Zec, with the difference that there's currently no way to spend any funds from this balance. The spending mechanism is yet to be determined by further discussions. And that's pretty much all I had for NU6, and I will hand it back to Alfredo.
Thank you, Marek. So finally, I want to talk about Zebra's role in the Zcash deprecation process. With the planned transition to a new stack, Zebra will be the sole validator node in the network. We have been collaborating with other teams to ensure that these transitions support existing use case while improving the overall infrastructure. From the beginning, Zebra has been actively involved in the discussions and planning for the new Zcash Stack. This stack includes a new Zcash wallet, which is called Salad, which will use the Zeno indexer with Zebra as the backend. Each team is developing its own component while maintaining close collaboration to ensure seamless integration. It is close to impossible, impractical, and unwanted for us for the new stack to be an exact copy of what Zcashd supports now. In order to be able to discard deprecated functionality and improve in other areas, we need to consider the use cases. In collaboration with other teams and individuals like Paku, the Zebra team is gathering information from different Zcash consumers, asking questions like what RPC methods do what transformation for development. To ensure the news works correctly, we have ported Zcashd Python-based RPC test framework to Zebra. This is an important step, but most of the relevant tests are wallet-related. So to implement this, we need to integrate Salad into the test framework, which is our next focus in this area. In regards to the Zeno indexer, we made several additions and modifications to Zebra, including new services and indices. In particular, we added a direct access to Zebra read estate service from other processes. We are pleased to see Zeno actively contributing to Zebra, participating in discussions and submitting pull requests. We expect this collaboration to continue as the development progresses. Next slide, Billy. Thank you. So this diagram represents the new stack designed to replace Zcashd full node functionality. At the left, we have Zebra, which serves as the validator and consensus node. Zebra has undergone multiple audits and is mature enough to handle this. Mentioned earlier, moving away from a monolithic approach in favor of a modular design. This modularity allows organizations to work in parallel on separate components while keeping the system flexible and maintainable. One of the most obvious steps in this direction is separating the wallet from Zebra. Instead of embedding wallet functionality within Zebra, we are developing a standalone wallet, Salad, which could interact with Zebra through its RPC interface. However, since Zebra focuses on some necessary functionality was missing. To bridge this gap, we introduced a new component, Zeno. Zeno acts as an intermediary between Zebra and Salad, handling additional indexing and state service needed for wallet functionality. It communicates with Zebra to obtain and process blockchain data, and then serves wallet with the required information. This architecture is more modern, more scalable, and more open, allowing independent development of different components. While there is still challenges to address, we now have a clear understanding of each component responsibilities, and the teams involved are fully committed to making this transition a success. I now let Gustavo to talk about running Zcash infra in production.
Thank you, Alfredo. So yeah, so if you can see, we'll have a new stack. We'll have like multiple pieces that we'll need to put up together to have like a full infrastructure working for Zcash. And thus we need also a way to run these easily for users. Not just like for people testing out Zebra, and even for them also like for allow new users to be able to test everything together easier, but also to have a way to run this easily in production. So we've been working around that to make that easier. Docker was one of the adoptions we made, so it's easier to make these deployments, like using a Docker run command. And when I say Docker run command, it's mainly that we can allow users to use a single Docker run command, and just like Docker run with the specified file, and with that file they can like run the whole ecosystem that they need or infrastructure that they need for testing purposes or for production use cases. Though for production use cases, we will focus mainly on creating other different kind of artifacts like Helm charts, so you can easily do a help install CFD, and depending on the different components that you like to run Zebra with, then you'll be able to have like different options or variables to define for those Helm installs. This is also will be very helpful, not just like for people testing out, for people deploying, but also for node operators that also need like a more easy way to include monitoring and all of that, though in different like that kind of tools. So we will provide users with these production-ready examples in our repository. Right now, the examples we have are mainly for testing purposes, but we were also working on getting ready these different Docker composes. Mainly, we'll start with the Docker compose files, so it's easier to understand like which will be the configurations that are secure enough for our production-ready deployment. As you can see, and some of you have been able to validate through our repository, and if not, this is part of the information. You'll be able to understand that we have integrations already implemented for LikeWallet, for Grafana, Elasticsearch, Kibana, Prometheus, Sentry. So we have all of that already working with Zebra, but not all of them are in a clear way on how we can use them and deploy them on our infrastructure. So that's also part of the next steps that we'll be doing on the following weeks. So we can also integrate all of these tools that we've been using around Zebra for the engineering team, for testing purposes, and put them into a way that you can deploy them into production for monitoring purposes, for testing with LikeWallet or different wallets, and even for the newest stack that we've been working with. So this is not just only putting examples up, but we've also been improving documentation around these subjects. So it's easier for you not just to try to understand like what's going on, but go through the documentation on a step by step on how to deploy these things. Now I'll pass on to Arya so he can talk us about some of the cleanups that we'll be doing next.
Thank you, Gustavo. So just the final things that we need to do is some cleanup. Um, there's already a lot of room for more tech debt in Zebra, so this isn't strictly necessary, but there is some low-hanging fruit that would be convenient to clean up before the next 6 months, before asset swaps, for example, deduplicating the code in Libra, Zcash, and Zebra chain. It would be easier for Kedit to just make those changes in one place rather than two. Removing parts of the network protocol that are left unused after Zcashd Deprecation. That's a new opportunity. It's pretty easy to take, and we need to document the network protocol anyways, so we may as well remove some parts that are unused while we're doing that. Improving error handling and conversions, particularly around the chain syncer. This is one of the few areas of Zebra that it's not terrible, but it's bad and it's easy to clean up, so we want to do that too. And then improving misbehavior tracking with more finely grained scoring. We have added a mechanism for doing this, but because we didn't want to take a lot of time to do careful analysis of what errors would be safe to ban peers over, we really only did the simple ones. So we need to do further analysis and add more finely grained scoring for the ones that are a little bit more nuanced. And then we need to simplify some legacy code that is now been stabilized into new Rust features. For example, async trait methods. There are some box features that we need to replace. And then if we get to it, refactoring the address book into a tower service would also be really, really nice for future development on top of the address book. And then the other thing that's next is performance improvements. So a push interface for notifying Zeno of mempool changes. Previously, we added a tonic RPC server in addition to our JSON RPC servers so that we could use a push interface, but the new JSON RPC crate that we're using offers that as well. So we can unify those RPC interfaces and add the new methods as usual. Advertising mind blocks to all peers rather than a small subset. As part of the fix for the advertising mind blocks in all network conditions, we now handle mind blocks separately from other blocks that have been validated, and there's an opportunity to advertise those to all of Zebra's peers rather than the small subset that's usually advertised to for blocks that are just validated. And then returning new templates immediately after transactions are added to the mempool rather than polling the mempool every, I think it's 5 seconds right now to check if anything has changed. This is already more responsive than Zcashd, but we have an opportunity to make it immediate, and the same opportunity, the same fix would also allow us to update Zeno immediately whenever there are mempool changes, so that's another thing we want to do. And then finally, replacing incremental Merkle tree with shard tree and parallelizing no commitment tree updates to improve initial sync performance. Even for the checkpoint sync, this is going to be a major performance improvement, I believe, as this is currently the critical constraint to Zebra's initial sync performance by far. And that's all for what's next on Zebra right now.
Okay, so now we're going to take some time for questions on Zebra, and we already have a few. So it's a question for the engineers. How does it make you feel that Zebra will be the sole consensus node on the network from NU7 onwards? And a follow-up to that is, how do you envision this impacting your daily operations? Anyone want to go? Otherwise, I'll pick on someone. Go ahead, Arya.
So I feel relieved in two ways. One is, so Dodger mentioned in the previous presentation that some have called the Zcashd code base a hellscape. Um, and while I have a lot of trust and respect for these engineers, and it's a thoroughly tested code base, I don't understand it, and that makes me nervous. So I feel a little relieved that we're going to be moving away from a code base that I don't really understand all that well. I also feel relieved because I think it's a prerequisite for everything else we want to do in Zcash, like proof of stake, bridging, scalability improvements, essays. So I'm glad that we can finally get on and do those things. And then how do I envision it impacting our daily operations? I'm guessing there's going to be a lot more review work. I'm guessing there's going to be more work in general. And there's going to be a lot more design work for new features because the opportunity is there now.
I'm going to add a little bit to the daily operations. I think it's a great opportunity to hear more from users of Zebra. I'm really looking forward to getting more features requests, more bug reports. Even I think it's very important to have things used in anger and discover how people using your software and how can it fail. And I think we need to be careful about how we scale. And I think that will involve documenting things a lot better. Where documentation is not up to scratch, we need to scale by documenting better and keeping track of what issues people encounter, documenting those and resolving those. And so, instead of answering the same question 20 times, you just answer it once and then point people to how to solve it. I think I'll move on to the next question now, which is, has there been any analysis on whether the ban mechanism could be misused? Specifically, if an adversary could cause an honest node to be banned, and I guess that's for ARIA also.
There will be before we start banning peers for more errors. Currently, there needs to be analysis done on that, and we're only really considering the simple errors that are very clearly going to result in bans.
Okay, I think we'll move on to Frost now. There'll be more time for questions at the end on Zebra and Frost. If you've not had time to think of a question, don't worry, you can still ask questions on Zebra. So let's move on to Frost now, and I'll let Conrado take it away.
Thank you, Pili. So we're going to talk about Frost, which is the second major project going on at the Zcash Foundation. So Frost is a threshold signature scheme, similar to multi-signatures, which you might have heard of. And the main idea here is that to generate a digital signature, we need a key, a private key. And the idea for a threshold signature scheme is that this key is spread into shares. So multiple people, they hold different shares of this key. And you can create a signature having just a threshold of these participants. So for example, you can have 2 out of 3, a threshold scheme, and then you will need 2 participants to sign something. In the context of Zcash, signing something is what you need to do to create a transaction. So for Zcash, this means you can create a wallet which is shared among multiple people, and where you need a threshold of these people to generate a valid transaction. This has multiple use cases in the Zcash ecosystem. One simple example is for your own wallet, you hold Zcash, but you want to increase the security. You could use Frost and spread your key into multiple devices, for example, your computer, a smartphone, and maybe a hardware device. And with this, if one single device gets compromised, you won't lose your entire wallet. Or if you lose a device, you could also recover the share later. This can also be useful for organizations. For example, there's an organization that manages some funds, Zcash funds, like a committee, a grant committee, or even Zcash Foundation or ACC, or any organization that participates in Zcash. If they want to manage some funds, they could use Frost, and then a single person wouldn't be able to spend that Zcash. They would need 2 out of 3, 3 out of 5, or really any number of threshold and participants to manage some funds. This has also been proposed for the cash governance, for example. There's a proposal that would involve the Zcash Foundation, CC, and other ecosystem participants to have shares of a Frost wallet that would manage grants. So I think this is really useful for cryptocurrency, but especially for Zcash. And Frost is the only existing way to manage a shared wallet of shielded Zcash. So this is also very important. So in Frost, we have two methods of key generation: trusted dealer, which basically someone creates the key and split that into shares. It's useful, but mostly for testing. What's more useful is the distributed key generation method, where a bunch of participants come together, they do a round of two rounds of communication, and after that they create a bunch of shares of a wallet, and the full key is never instantiated, which is really cool and really good for security. So what we have at Zcash Foundation, what we have developed regarding Frost is basically a bunch of crates. The main one is called Frost Core, which implement Frost, right? The cryptography part of the protocol, which is like the main part, of course, but that's not enough, because to use Frost, you need some communication between participants, and those crates don't handle that. The caller needs to handle all communication, and the crates just really do the cryptographic part. So in order to address that, we have developed additional tools. FrostD is a HTTP JSON server that helps participants communicate, because on the internet, people are behind firewalls and ATs, and that makes hard for people to connect directly with one another. So FrostD helps with that. We have developed Frost Client, which is a command line tool that uses FrostD to run Frost. You can create a wallet, you can sign with your wallet, and allows the concretization of Frost. And there's a Zcash sign tool. It's a standalone tool that probably will be incorporated into Frost Client, but that basically bridges Frost with Zcash. So this tool reads a wallet generated transaction plan and output some information that you need to sign, and then you get the signature, put in that tool, and we will generate a signed transaction, which you can broadcast. And that will be shown in the demo upcoming. So what are the updates since the last Zcon? The RPC was finally published. I mean, it was ready for some time, but just the bureaucratic process takes some time. So it was finally published. It's now a RTF RPC. In Frost Core, some improvements, like we added no STD support, so you can use like in embedded devices. We added coupled identification when you're doing the KG. We added a new cipher suite, which can be used for Bitcoin taproot compatible signatures. This was interesting because it was mostly community contributions. We basically cleaned it up and reviewed it, which was nice. It's cool to know that this is being useful and people are contributing to the project. But also, I think for Zcash, the main thing here is that taproot signatures will also be used for issuing ZSAs. So ZSAs are Zcash shielded assets, which are coming the next Zcash network upgrade. And like we can issue tokens, NFTs or whatever, wrapped tokens. And to issue that, the issuer needs an issuance key. And this issuance key is really important. If someone hacks it, then they can issue anything. So with this surface suite, you can use Frost to protect the issuance key, and you will need like 3 out of 5 or any type of threshold to issue an asset on Zcash. And we also add the support for refreshing shares, which is an interesting functionality that helps keeping your shares secure. So just to explain what we're going to show in the demo, this is the updates. So FrostD, the server, last time on the last Zcon, it was really very simple, and now it's fully featured. We now support multiple cipher suites. Actually, the server doesn't really care what you're using. The server now supports private key authentication. We get rid of username and passwords because it doesn't make sense to the solution. And also support multiple sessions. So it's like this is a really usable tool now. In Frost Client, we added user registration, authentication by using this feature that I mentioned in FrostD. We added end-to-end encrypted communication, so the server can't really see what's going on, what's being sent to it, which is also, of course, really important for privacy. And Frost Client also does now contact management. This authority did an audit. It's a current in progress audit, but they had an initial report and didn't find any high-risk findings. And we have also already, at this moment, we are addressing those smaller findings, nothing critical, but some important stuff that we are addressing. So the idea is here is for these tools to be useful by the Zcash community. So what's next? What's missing on this project? We believe we kind of have wrapped things up, but there's some key important but not big things that need to be done. We need to do some improvements to Frost Client, basically to add PCC to support, which are partly created Zcash transactions. This is something that has been added for Keystone hardware wallet support, but can be useful for Frost. Frost can use the same mechanism. And Frost Client needs to show the transaction plan before signing. I'll explain this during the demo. And of course, the next big step will be integrate Frost with wallets, right? Because the command line tool is cool, people can use it, but of course, for the regular user, graphical interface would be much better. And we're hoping that wallet developers will be interested in integrating Frost. We can't do everything on our own because we need to focus on Zcash deprecation, but we are willing to help. We know that Zingo is interested, but they also are very busy right now. James Katz is working on proof of concept of graphical tool to wrap around our command line tool, which seems really cool. So look forward to that. And something that I also think is important and that's missing is Tor support for this tool, because the server can't see what's going on, but they can see who is communicating to who. And with Tor support, this privacy risk would be mitigated. And I think we can start the demo. While I just need to set things up here. While I do that, I'll just talk briefly about what changed, right? So there was a question on Huba about this demo being similar, if it was going to be similar to previous demos. On ZconVI, it was everything copy and paste. It was like a proof of concept, really, but terrible usability. At Zcon5, we already had online communications, but really all the contact management, encryption, authentication was missing. So now we have those. I mean, the demo overall structure is the same because at the end of the day, we are signing as a cash transaction using Frost. So the overall steps are the same, but it's just now we believe things are much more ready to use now. So let's get started. Hopefully you were able to see my terminal in my camera. So we're going to do this demo with Natalie John, which are here. And the first step would be to initialize my profile, my config file. I already did that, so I'm not going to do it. But what we need to do now, so our goal here, the first part of the demo is to generate a new Zcash wallet using Frost. So, but before we do that, I need a way to share my communication public key with Natalie and John. So for this, we have this command called Frost Client Export. I just need to put a name which will show up for the user who is porting the key. Could be an alias. So it generates this context string that I need to share with Natalie and John. So I just post it on the Zoom chat we have here. And now I can switch maybe over to Natalie to start her key.
Hi. So first. And then I will send this as well. John?
Sorry, I was muted. Okay. Yeah, let me run the export real quick, and then the import. I already have all this stuff. Okay.
Is the context string the final one?
Sorry, where am I at? This one. Yep. Okay.
Cool, thank you. So now Natalie and John have pasted their context strings. So I run Frost client import with Natalie's key, and then with John's key. And there you go. I have their contacts. I have John Natalie's do it for testing we had done earlier, but here I have John's and Natalie's keys. So now we can get started. So I want now to create a new Zcash group, a new Frost group, sorry. I'll call this ZF demo group 3. The server we're going to use is the development server we have up. And I need to specify the public keys of the participants. So I just grab Natalie's public key and John's. Cool. So around this command, so I'm running the DKG, the distributed key generation, with Natalie and John. And they now need to run this command, but they can omit, they need to omit this S parameter. So I can switch over to Natalie.
In group 3.
Cool. And then John.
Okay. On group 3.
Yeah.
Okay.
Cool. It's happening. So there's round 1, broadcast round 1, round 2. And then finally we have completed Frost DKG. So now we have a shared group. So we generated a Frost key, but we only have the shares. The entire key was never generated in memory anywhere. So here's the group we have just generated. So what I'm going to show now is how to turn this into a Zcash wallet. So for this, I'll run this Zcash sign tool that I mentioned earlier, and that you probably incorporate into Frost client. So I need to grab this public key from the group you have just created. And if I run this, I get an orchard only unified address and a unified full viewing key. So I'll copy this unified full viewing key, and I'm going to switch to my wallet accounts. I'm going to add a new account. I'll need to put a name, just Frost group 3. And I click restore an account, and I just paste the unified full viewing key that the tool had printed before. And if I add that, I get a brand new Zcash wallet, and I can send funds to it. But no one will be able to spend it unless they do the Frost signing that we're going to do next. One important warning here is that if you're following this and if you're trying this tool, you need to be careful that due to a technical limitation with YWallet, it doesn't support Orchard-only wallets, so it needs a sapling component. And this is why I had this flag danger dummy sapling, because you're generating a dummy sapling component. And if you send funds to that, you will lose your funds. So you need to send funds to the Orchard address that you can get by swiping your screen. So be careful with that if you're trying this at home. So what I'm going to do now, we're going to create the Zcash transaction. So since we don't have funds here, we're going to switch to an account we had created before. That it does have some funds. So let's go. I'm going to create a transaction plan, which basically is, I just need to simulate creating a Zcash transaction here. So I'm just grabbing an address. I'll use this address, which is for the Zcon clip contest that's going on right now. If look that up if you're interested. So I'm going to send 01 Zach to it, and let me click here. It will show me the transaction plan for this transaction. So the details, how much I'm sending, what's the fee. And I need to click. Sorry, John, can you mute your? It's just I'm getting.
Sorry.
No, it's fine. So I'm going to get this transaction plan, and I'm going to click here. So what this icon means is that this is a wallet that it's a cold wallet, right? It doesn't have the spending key. So if I click here, it gets me a QR code, but I'm not interested in QR code. I want a file. So I'm clicking this disk button, and I'm going to save this at transactionplan.json, right? So my wallet creates a transaction plan, and I'm going to run the Zcash sign tool over that. I need the unified filling key, but for the thing, the wallet we had created before. So let's go. It gave me a sig hash and a randomizer. So what I'm going to do now, I'm going to run a coordinator. So the coordinator is a party that initiates the signing process. Let me get the group wiki for this group, and then Natalie's and John's public keys. So I'm going to run that. It needs a message. So the message is the sig hash that this tool has printed. And the randomizer. It's just a technical detail, I won't go into it, but we need that to sign. And now Natalie and John need to run the participant command, and I'm also going to run it because I can also be a participant. Be careful, Nat and John, to pick the public key from demo group 1. It begins with AF. So yeah, I'm running this command.
Okay.
Something went wrong, sorry. Oh, I forgot to include myself. So yeah, Natalie and John should be able to do this.
Great. I'll go first. That's the group for the demo group 1.
Okay.
John?
Yep.
So both Natalie John's tools generated commitments sent here to the coordinator, and the coordinator send a signing package back to them. So just they received a prompt to see they're going to sign something, and it's showing them a sig hash. So this is a really important thing I need to emphasize, is that this needs to change. The tool needs to show the transaction plan, not just a sig hash, because otherwise they can't really know what they're signing, right? So this is one important thing we need to change. It's going to change soon. But there's a prompt there, so they need to choose if they want to sign or not. So they're just going to press yes. Go ahead, please.
So, yes.
Yes.
And there you go. Me as a coordinator just got the shares from Natalie, the signature shares from Natalie John, and I got a signature. So I just copy the signature and paste here in the Zcash sign tool, and it wrote a signed transaction to this file, which I can go back to my wallet, click broadcast. I need to pick the file here from documents, tx signed, click OK, and it has finally broadcasted the transaction to the Zcash blockchain, and there you go. It's unconfirmed. It needs to wait a little bit until it's mined, but we have just created a Frost-signed Zcash transaction with people all across the globe, which I think is pretty cool. So thank you, and I'll hand back to Billy.
All right, so we have very little time for questions, but let's try to get through them. So the first one is minting and burning of ZSAs within our Frost implementation scope and testing cases?
We haven't yet integrated with the ZSA tools, but yeah, that's I think it's a very important thing to do, and probably closer to when ZSAs get activated on testnet, we can probably start working on this. But yeah, we need to schedule everything, but yeah, this is something that makes sense, yes.
Okay, next question. What additional development work would be required in Frost for real users to be able to use it in Zcash?
Sorry, can you repeat that? I'm not sure.
So is there any, so apparently the question is kind of, Frost is not ready to be used by real users right now in its current form. So what else, what more development needs to be done in order for this to be possible?
I feel like we have all the technical pieces into place. What we need now is interface integration, right? So what's missing is for wallet developers or any other developer really which is interested in make Frost usable. To get this thing we have developed, you need to either import our code or just use an aspiration. But basically, the goal of this tool we have presented is both to be can be used as a library or just a reference, right? So the step missing now is for developers to integrate these tools with graphical tools, which would be much more easier to use.
And I'm so sorry.
No.
Yeah, we really welcome any collaboration. So please do reach out.
So kind of a follow-up question is, what is the anticipated timeline for Frost to be production ready?
Yeah, it's a tricky question because I think Frost is already production ready, right? But I see from the regular user perspective, they can like really use it right now. But I think it's outside of our hands since we can work on the graphical integration. The Zcash Foundation can work on the graphical integration right now. I think it's up to the hands of the ecosystem developers.
Another follow-up question. Have we reached out to Multisig or Maya Protocol regarding Frost? And is it something that we might want to do?
No, we have not reached out, but it seems interesting to look into, yes.
Let's check if there are any more questions, but I think that's it. And oh, there is one more question. And then I think this is the last question because we're already at time. But is there a plan to maintain the server-side infrastructure for this? So that's the Frosty server, or are teams expected to host their own for each project?
That's a great question. We have a development server up that people can use to, try this tool out. But we have to discuss if we want to have like some, production servers up. We don't have concrete plans right now, but we're going to explore that soon. But I think it's a very simple server to get up and running. It doesn't even need a database. So I expect people can also run their own easily.
Okay, thank you, everyone. Thank you to my team for participating. That's kind of all we have time for today. And thank you to the audience for listening. I hope you enjoyed it. And that's all from us.